5 is okay to start with? And all that will be on there, or we okay with 5 as well? We want to put 5 together or no? Okay. Given a standard normal distribution, find the percentile rank for z equals 0.35. Okay, so we know right here where the mean, we just saw on the previous page that wherever the mean at, your z is 0, because z is how many standard deviations you are from the mean, so at the mean you're 0. So if we're looking for 0.35, we know we're just a little bit above the mean, not quite half the standard deviation above the mean. And we're wanting to know what percentile will that put us at. So really what they're asking us for is, what is that area? They're asking for area. That's just a way to ask for it. Percentile, that means how many people are where you're at or below you. Okay, so when you're asked for area, how do you handle that? Do you remember what button you go to? You're looking for area? Awesome. If you forget, is it the end of the world? Nope. Because you can start opening stuff up, and if you don't have the information that it's asking for, open something else up. It doesn't like it when I open it up the first time. Let me disconnect and get it opened up. Alright, so I'm going to go to second. I want distribution, and I want normal CDF. And I already know what my boundaries are because I did my shading. So if we're reading it from left to right, we want low, some really low number. I like to use -999. I'm going to 0.35. Anytime you're talking about a z, that's standardized, right? So we're going to use what for the mean? Beautiful. And for the standard deviation, 1. And most of the time, if your calculator's been updated, it'll prompt you for all of this, and 0 and 1 will be in there. And you hit enter, and you get 0.636. So we're looking at the 64th percentile. If we do the same thing for B, I'm going to come up here, we'll go normal CDF, -9999 to -0.2, 0 and 1, and I got the 42nd percentile. For C, what would the percentile be if you're actually on the mean value? What would it be? 50. Awesome. You can crunch that number, but you should know that. 6. A set of SAT scores, SAT scores, has a mean of 475, a standard deviation of 80. If this distribution is approximately normal, find the percentile rank of a student whose score is 490. Okay, so let's see what that picture would look like. We've got a mean of 475, so that's obviously where z is 0. Standard deviation is 80. And we want to know the percentile rank if your score is a 490.
Mr. Thompson, I did that 42.
Oh, right here. Okay, let's see. Let me grab my calculator. Maybe I typed something in wrong. Second distribution. And it's entirely possible that I've typed it wrong. I got 42. Yeah. percentile rank, so this is a fancy way of asking for area. Now, let me ask you a question. Do we have to go through the z-score on this one? No, because they gave us the actual mean and the actual standard deviation. Could you find the z-score first and then use 0 and 1? Yes. Just pick your method, because if you try to combine the two, you're going to miss it. You either go raw data the whole way, or you change it to a z-score. I will tell you it's quicker just to do what they give you, right?
So you would go inverse normal, please?
No. We're still asking for area. Anytime we're trying to find area, it's normal CDF. The only time you use inverse normal is when you flip it and they give you the area and ask you for some data.
Okay, I was thinking about the question.
Okay, awesome. So, but let me show you, this is kind of an easier way than what we've been doing because we have a little more information. Go to normal CDF. Our lower bound, we can leave -999. Hey, what's our upper bound going to be on this one?
490.
Awesome. Okay. Now, we do not want to leave the mean 0 and the standard deviation 1. We will change the mean to 475 and the standard deviation to 80. Good page. 57. Okay. Do you see the difference between the two methods?
Yes.
If you got a z-score, you don't have a lot of options. You've got to use 0 for the mean and 1 for the standard deviation. But if they give you the actual mean and standard deviation, you can do it this way. Depends on what's given. Okay. All right. Find the area between z equals -0.2 and z equals 1.5. So here in the mean is where z would be 0 because we're 0 standard deviations away. 0.2, we're going to put that right there. And then 1.5, we're going to put right there. And we want that area.
So 0.2 would be your lower bound, and 1.5 would be your upper.
Awesome. What would your mean be?
0.
And your standard deviation?
1.
Beautiful. Okay, and so if we type it in the calculator, I'm going to do just what you said. 0.2 to 1.5, 0 and 1. And anybody else get 0.35? Thereabouts? Okay. Number 8, given the SAT scores from problem number 6, what percentage of scores fell between 450 and 525? So we're looking at lower bound. That's our upper bound. And according to the problem, our mean is 475, standard deviation of 80. If you put that in normal CDF, I got 36%. The only thing I want to caution you about is just remember, don't mix the two up. If you want to use the z-score, you standardized it so your mean by definition is 0, your standard deviation is 1. If you want to do the data, you change your mean and standard deviation of what's given. Okay. The B part says what number were greater than 600. So in that case, I got 0.059, which is about 6%. 600 was my lower bound, and some ridiculously big number, I just made it 999 was my upper bound. My mean was 475 for my standard deviation. Number 9. What score must you achieve on the SAT to be in the top 10% of all scores? Same mean and standard deviation as number 6. Alright, let's be careful about what's being given here. They said we wanna know what happens if we're in the top 10.
So it would be 14.
Awesome, and so what's being given?
The mean and the standard deviation in the area.
In the area, if you're given the area, we're switching buttons on the calculator. We're going to inverse normal. So a picture with, notice how all these were shaded and I had a question mark in here because I didn't know the area and we use normal CDF. Well, let's look what this looks like. And we want to be in the top 10%, which is right here. So what Bonnie said is right. That's this part over here would be 9. If you're in the top 10%, your area is that you're at better or equal to 90%. So that's awesome. And then we want to know what value would put you there. Okay. So I would go to my calculator. And this is another case where I could find the z-score for 90% and then go from there. But this is a one-step way to do it. Since I know that the mean is 475 and the standard deviation is 80, I can just go straight to it. As opposed to finding a z-score for this and changing the z-score. This is a little more straightforward. And that gives me a number of 577.5 around. What percent of the values in a normal distribution are greater than or equal to z is equal to negative 1.677? So we're back to being asked for area because it says what percent. And call this z is 0 here. We're going to make that negative 1.677. And we want to know what percent is greater than that. So I'll go to my calculator, and remember when you're, I always go ahead and define, there's my lower bound, my upper bound, a big number. And I'm going to, on the multiple choice part, of course I'm not going to see tomorrow, but when you get ready to take your AP, make sure we're getting in the habit of putting our probability statement. And when I put that in, I actually got find the area under the curve between negative 2.34 and negative 0.5. That actually needs to be looked up a little bit. And I got 58%. So the probability that z is greater than negative 2.34 and less than 0.5, and we do normal CDF, and I got it. I think we've worked enough of these. The answer to 12 is 58%, and you do not have to use a z-score. You can just put your data in. The answer to 13 is 19%. And let's go ahead and do this last one, number 14. Are y'all familiar with this notation? I guess I need to start there. With a big N and 72,8, do we know what that means?
Would it just be normal?
It's telling you that the data is either normal or approximately normal. Actually, I think the capital N means that it is normal, and it's telling you that it has a mean of 72 and a standard deviation of 8.
Is that going to be on the chart?
That notation, possibly. I can't exactly remember, but yeah, and that's a good one to know. That's just a way of saying that whole sentence in that little bit. For a distribution that's normal with a mean of 72, standard deviation of 8, find the raw score that has a percentile rank of 80. So, are we being given area or asked area? And how do we know we're given area? And percentile is a form of area because, like, if you're at the 80th percentile, then that means the area that you're better than is 80%. So, here we go. We know you're here, or whoever has that raw score is here, and here is at that 80th percentile. Okay, but what is that raw score?
So this is an inverse one?
Absolutely. So you're going to go to your calculator and you're going to do inverse normal, and the first thing it asks you for is area. So if you're reading through your problem and it doesn't tell you a percentile or an area, you're in the wrong place. So when it asks you for area, put 80 percentile, 0.8. Then it's going to ask you for the mean, and then it's going to ask you for the standard deviation. And when you do all that, I got 78.7. So that's the score that will put you at the 80th percentile.